All right, with an understanding of diversification, understanding now in practice how we would apply the principle of diversification, I want to talk about a subtle principle that is super important when we're talking about investments analysis. All right, so let's suppose we have two assets. Let's call it stock A and stock B. Okay, stock A pays off has this much risk and has this much expected return, whereas stock B has this much risk and pays off this much expected return. Okay, so you've plotted these two stocks. One of the really most interesting principles in finance is how covariance can actually improve the performance of portfolios. So if I were to ask you, so what would happen if we put 50% of our wealth in stock A and 50% of our wealth in stock B? If I were to draw a line between these two dots, many of you would say, well, if we put 50% in A and 50% in B, we would just be here, right in between. Does that make sense? That's a reasonable assumption. However, there's a statistical property, a law actually, that says that the variance, or you can think of the standard deviation, anyway, the variance of A plus the variance of B, the variance of A plus B equals the variance of A plus the variance of B plus 2 times the covariance. Some of you are asking, what is covariance? So let me show you a picture of what covariance means. So if these are two variables, as smaller values of X and smaller values of Y are correlated, does that make sense? Do you see how there's a correlation of positive covariance here, where large values of X are correlated with large values of Y, right? In other words, in the framework of what we're trying to do, suppose we're trying to find the covariance of two assets across time, and let's say asset A goes up 1%. Likewise, asset B also goes up 1% during the same time period. In the second time period, asset A goes down 2%, and asset B also goes down 2%. Do you notice how they're moving together almost perfectly in this case? So they would have very high positive covariance. On the other hand, if there's a negative relationship between these two numbers, between these two variables, so think of this, if asset A goes up 1% and asset B goes down 1% in the same time period, and then in the second time period, asset A goes up 2% and asset B goes down 2% in the next time period, does this make sense? They would have perfect negative correlation, or they would have very high negative or very negative covariance. Does this make sense? So it's how the two variables move together, basically. Okay? So this is important because if the covariance is negative, then the variance of a portfolio made up of A and B can actually be lower than either the variance of A or the variance of B because the covariance is so negative. Does that make sense? That's super important to understand. So if I have 50% of my wealth in asset A and 50% of my wealth in asset B, I'm not going to be right here in the middle if the two assets negative covary. What happens is I start to bend off of that line, that imaginary line that I drew between A and B. I start to bend off that line, and depending on how negative that covariance is, I create almost an imaginary frontier of where I could get. Now notice something. If I were to separate this graph into 4 quadrants, and this upper quadrant I were to call quadrant 1, this other quadrant I'd call quadrant 2, down here I'd call this quadrant 3, and this quadrant 4, where would you want to be on this graph? Hopefully you're answering to yourself, you want to be in quadrant 1. This is the place to be. I have low risk and high expected return. Does that make sense? So when I have negative covariance between the assets in my portfolio, I start to bend toward quadrant 1. Let me give you a graph of this. This is called the Markowitz efficient frontier. Okay? Notice, so if I put all of my assets in asset B, I'm here. If I put all my other assets in asset A, I'm here. And notice there are an infinite number of portfolios that I can create with those two assets, right? I could put 1% in asset B, 99% in asset A. I could put 2% in asset B, 98% in asset A, 3% in asset B, 97% in asset A. Does that make sense? I can create an infinite number of portfolios. And all of those portfolios will exist inside of this frontier. Okay? I can't extend beyond this frontier. The question is notice, I have a whole bunch of portfolios. I have a whole bunch of portfolios on this frontier. Which one do I want? Again, if I broke this graph up into quadrants, where this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, I want to be in the most northwest quadrant. So I would select the portfolio that's on the efficient frontier in this area. If I do that, then I am maximizing my expected return subject to my volatility, or the ratio of the expected return divided by volatility. Now notice, if I hate volatility, I don't want any volatility, I'm very risk averse, then maybe I would select a portfolio here that has the lowest volatility. But if I understand the trade-off between returns and risk, then I want to be in the most northwest quadrant. That means I'd select a portfolio somewhere along this part of the frontier.